If you're thinking of getting a heat pump from Octopus Energy, then this video is going to be showing you my install. This is currently day 4. In a minute, we'll go back to me on day 1 and how it all started and how we got to the point of this getting finished. But if you're thinking of getting a Cosy6 or any heat pump from Octopus Energy, there is a link down below in the description to split £200 off with me.
Heat flexibility director, so I worry about all of our heat flexibility products, and those are for most customers tariffs around how we better control and optimize heating in the home.
Let's talk about what I've had to do and what you'll have to do as customers before Octopus even start. Now, if you're having a tank in a loft like mine, they will tell you need to board it out. And the instructions they gave me weren't particularly clear, and I fed this back to Octopus and they will improve them in the future. But basically, I boarded out the loft, and I actually caused some problems with boarding it out because I boarded it right up the loft hatch and the entire length and left this small gap here in the middle for them to put the tank. The engineer said it would have probably been better if I just left the space out near the gable end and they could have fitted it round there. The other thing we had to do before Octopus started is fit lighting. So they need light switching if they're working in the loft. So my loft boards are sat on legs, and that's so we don't squish the insulation value, because if you get a heat pump, you want the house to be well insulated so it has less heat loss and the heat pump's not working as hard. Full costings for that and down below at the bottom of the screen. So what used to be here is a couple of bushes and a tree, as you can see over there. So I've had to dig them out first so then they could lay down this base. Now the base on the Cosy6 is a little bit different to a traditional heat pump base. Some other heat pumps, they come with feet, rubber feet, and where this has actually got a solid base. That to speed up insulation, or is this for noise reduction? Why have you picked this method?
The firm base is a function of the form factor itself and needing to fit all of these things in here in a very different structural shape than we would have had, if we'd used sort of the old box method approach.
The electricians, 2 of them, have been very, very busy today. So we've got basically a cable that's not been connected up yet. That's going to go in the DNO box eventually. But that's the supply power for this consumer unit. This outdoor consumer unit has been fitted here. We've got 2 supply cables coming out of here. One's for the Cosy and one is for the hub and also the immersion tank. So the immersion tank can be heated by electricity. You would be better obviously heating it up by the Cosy6, but you can obviously have an emergency supply if you need the instant hot water. But this cable here, 2 cables run up here and they follow the route of where my solar supply is. So they've clipped that up with the solar supply and it's followed the solar supply up and towards the loft.
2 weeks ago at the factory, went down the line and put together a Cosy. I'm fairly certain it's not this one, but there is one out there that I've put together.
Tell us the serial number so we can just make sure, check your homework.
We'll leave it a mystery for some lucky customer. But essentially a heat pump is a refrigerator or an air conditioner running in the other direction. So if you think about your refrigerator in your kitchen, it is taking the heat out of your refrigerator and putting it into the space around it. A heat pump is doing that in reverse. It is taking the ambient heat from the air outside your home and it's pulling that air or pumping it into your home.
Day 2 in the loft, which is now a little hot box. It is absolutely sweltering warm in here. We're in the middle of quite a warm week and obviously a lot of plumbing work going up here and a lot of engineers have been in here. So quite a lot's happened here on day 2. First of all, we've got the pipes now running from the cylinder tank to start the system up. So we've got a flow and we've got a return pipe. Then we have a hot water feed and obviously the cold feed. Now this is all running to the cylinder tank. A couple of filters and a couple of bits have all been attached to the tank, and the rest of the plumbing here is attached to the tank. You can see this is obviously the cold water loop feed here for the tank and various bits. But what they're going to be doing is going to be pulling up the pipes through my room downstairs up from the boiler that's currently sat in the kitchen. So you've switched this to propane?
Correct. You'll see it referred to as R290, which is a new refrigerant. It's a natural refrigerant. Obviously propane is a naturally occurring gas, unlike what we've used before, which was R32, which you'll see in a lot of the units on the market. But the whole industry is moving to R290 because it has a much lower global warming potential than refrigerants we've used in the past that are equivalent to several hundred or even thousands of kilograms of CO2. R290 has a global warming potential of about 2 or 3, so it's almost the same as CO2. So if there ever were to be a release of refrigerant, it's much safer for the environment than it would have been in the past.
We did have another small problem this morning almost. We had the gas engineer turn up from Octopus metering team to disconnect the gas, and they sent the lad packing. He wasn't meant to be cancelled and rearranged for Friday because they're running a little bit behind on my job, and basically they've asked him not to disconnect the gas until they've got this whole system working here.
So this Cosy6 can work down to about -25°C, and then you would start to see a performance drop off, which hopefully is colder than we would ever see in most of the UK. But that is a pretty standard range for most heat pumps on the market, is to get down about that cold, which is why you see them working in places like the US, where you have wintertime temperatures that are much lower than what you typically get in the UK. And that can be something that's hard for people to picture, but I often refer back to that concept of a refrigerator, right? Even in the middle of summer, when you walk into your kitchen that feels very hot, your refrigerator is still cold inside. Heat pumps are very similar. Even when it's cold outside, there is still heat to be scavenged by this process and moved into your home.
If it goes to -30, the heat pump doesn't just stop working.
It doesn't stop working. You'll just see a drop off in efficiency, right? There's a range in which it works to its best efficiency, and outside, of course, it still works. It's just not quite as good as it would have been.
Now, the other bit of remedial I had to do is take out this section of plaster here, because I didn't want the pipes surface mounting. I didn't want to box them in afterwards. I wanted it basically into the wall. It's a new build house. I wanted to keep it kind of without pipe surface mounting and boxing in sections in if I could. So I took this plaster out. I peeled back the insulation, which is in here, and I thought that'd be it. I moved the bed out of the way so they could lift the floorboards up, and they lifted the floorboards up, and I got a text off Rick. I wish I could show you, but he screwed it back down, so I might show you another day. But basically saying there's a double joist in the way and they can't get the pipes. And they gave me a couple of options. One, we could try and do a little small box section down here, or so you join me on the other side of that wall. Round here is where we took the plaster out on the other side. They've took this section of wardrobe up. They've moved the wardrobe slightly back at the moment. But basically they've made a little access hatch here so they can get the cables, so they can get the pipes from the boiler up, and they managed to do it. So you've got to kind of, understand that everything's not simple in a new build house. Everything's not simple in an old house. And plans might have to slightly change from what you're looking for. We're finally now starting to take the final shapes here. So let's talk about what they've done. They've put the trunking in here. Now the trunking has been a bit of a nightmare because of this stone that I have on the way my house is built. It's not a smooth surface, it's quite bumpy. And because it's bumpy, it's caused the engineers a little bit of a nightmare trying to get it as flat and as smooth as they can, because they want it to look level and they want it to look smooth, but they also need the pipes to fit inside it with the insulation. So they spent quite a lot of time with that. Now the electricity cable for the Cosy6 will run with this trunking, so it's all nicely hidden away. Now they talk you through this when you're having your install and planning done on where you think the pipes are going to go. So I was expecting this. I asked for trunking, I paid for trunking. Trunking is an extra, and I do believe that if you want aesthetically pleasing as possible, you want the trunking. Yes, so there is probably different ways of routing this cable. Yes, there's different ways of doing it, but for the price that Octopus charge, which is way under £2,000, it's well worth, in my opinion, to have it trunking done like this, rather than trying to spend extra money for something that isn't really that much of a difference to me personally. Now they've put on the Cosy6 onto its base, so I'm quite looking forward to this being put together tomorrow and the engineers possibly filling and refilling the system to get the radiators on. Cosy6 6 kilowatt of heat
Exactly.
pump. Okay, that doesn't actually mean that it uses 6 kilowatt of power from the grid though, does it?
No, and that's where the concept of your coefficient of performance comes in, where it can serve a heating need of up to nominally 6 kilowatts, but it uses a much lower input power to do that. When someone says that their heat pump has a SCOP of, or a COP in this case, of 3 or 4, it's using 3 to 4 times less power to create the heat than the heat that comes out of it. Cosy6 right now is the smallest that we have planned, and that will serve homes down to, again, your size, and even newer ones that might have even a little bit lower heat loss without any issues with cycling or excessive running. So this is the optimal size for most small homes in the UK and some medium-sized homes that are a bit newer and have that low heat loss because of high insulation.
Okay, so by that, I presume you're hinting that there's going to be a bigger version of the Cosy6, maybe a Cosy 8 or 12?
We do have some bigger things in the works, so I'll keep the numbers close to the vest, but we do have some larger heat pumps planned to serve, obviously, the whole of the market. Maybe that 10 or 13 or 15 kilowatt size.
One thing I've noticed when I posted this on Twitter, picture of it, it draws two different views. It draws people that love the look of it, like myself, I prefer the look of it, and it gets the people that don't like it. And they tend to be heat pump engineers that can't buy them off you, typically. But you've gone for a different design. You've gone for this different shape altogether. But you've also gone for different materials. Like tends to be metal casing on most heat pumps.
So we have gone with a plastic casing. So this is a weather and UV resistant plastic casing that allows us to do some very different things with the form factor inside and externally that we couldn't do before and that you can't really achieve with metal, or at least not in a cost-effective way. Unlike a lot of heat pumps on the market, this one is taller than it is wide, where most everything else you buy is wider than it is tall. And in most cases, people have a lot more room vertically than they do horizontally or frontally. So it makes sense to think about that form factor in a different way.
On day 3, not really much to show you, but we basically connected the hot water and cold water supply to the tank upstairs, which means they could now disconnect the boiler from running the heating for the hot water and taps, which means that they showed me where the emergency hot water switch was. So the Cosy6 will heat all the water in the tank up to 60 degrees quite happily, but there is an emergent supply up there, but I need to physically flick the switch. So if the Cosy did fail, just go on the loft, flick that switch, and I've got hot water instantly in the case of an emergency. But that's pretty much all we kind of did on day 3. All the rest is just kind of pipes in the wall, so not really much to see. It's very, very different to what we've seen in typical heat pumps. I've noticed a couple of things that you've done differently, and I'm not, I'm just a bit of a geek when it comes to sort of looking at stuff.
Where you need an expansion vessel normally, this is now integrated into the unit itself. In most installations, your biggest cost factor is the time on site for the labor. For our lead installers or electricians or plumbers who have to do all of that hard work fitting things in the home. And one of the big advantages of the Cosy is how we have simplified the install, especially from a wiring perspective. So this is made to be moved into position easily, hooked up very easily in the back, and it's a much simpler wiring process than other heat pumps that can use sometimes 4 or 5 different cables coming in. The entire form factor is designed for a faster install, which is the goal. Because it reduces the time on site and the cost for the customer and allows us to get more heat pumps done in a week.
Yeah, and you put some other valves in here and other parts, but not just the wiring, not just this expansion vessel, but there's some other bits for the engineers that normally would have been fitted separately outside the heat pump, because now they're just putting the pipes directly into the back, aren't they? Where before Correct. They would have had a lot more auxiliary bits on the outside.
Basically anything that we could take from the outside we have put inside, but we have an entire system here that is made to pull all of those little ancillary things that you mentioned into the heat pump itself to reduce the amount of time that you have to spend fitting those things into an airing cupboard or elsewhere external to the unit. But we do gas it at the factory, which is important because one, it allows us to make sure there's no leaks. So we do a full suite of leak testing beforehand with some obviously very specific and advanced machinery to detect any potential leaks in the refrigerant circuit. And then we fill them and leak test again, so we know that these things are leaving the factory with a complete and sealed circuit.
So TJ, when the MCS report came out for the Cosy6, a lot of your competitors were overjoyed with the results because they saw that it wasn't very efficient. It was less efficient than the current unit you already fit, and it was going to, you brought out this new heat pump, this new technology, and it's just not hitting the efficiency numbers. I mean, is it less efficient?
No, it's not less efficient. And I think first and foremost, those are honest numbers that were the result of actual production models going to an independent tester, because we don't want to try to hide behind values that aren't reflective of what people would see in real life. And the good news is that of the Cosys we've installed, we see efficiency that is equal to or better than the similar model Dakins we had been installing before. So, the acid test of the efficiency of a heat pump is how it performs in the field, not in a laboratory or on a table of numbers. And in that sense, we're very pleased with the efficiency of the Cosy6 and how it's working for customers, and we stand behind it as a very high efficiency unit.
Am I assuming that the efficiency that this heat pump has at the moment, knowing Octopus and the way you work with software, will gradually improve?
Well, we like to think that everything we do will gradually improve. And as we learn more about the Cosy from how it performs over months and years in the field and the way customers use it in real life, I think you could expect that we would certainly tweak the design over time. Our heat pumps are capable of over-the-air firmware updates, which means that when we find ways to improve the functioning of the unit to make it better for customers, that we can update your heat pump basically through your Wi-Fi. So you, in a sense, always have the latest version of the Cosy software running your heat pump. And so when we do find those opportunities to improve, we can make sure that customers get them.
Okay, and some other issues that might occur to people is, let's say I get a Cosy6 heat pump today, and I leave Octopus.
We hope you don't leave, but if you did get a Cosy heat pump, it does not lock you into Octopus for life. We think we can keep you for life by offering you the best products and the best value and customer service. So this is not a backdoor way to lock you into Octopus. We commission all our heat pumps right now at 50 degrees for flow temp, and obviously that is higher than some people may do, but it's also much lower than the maximum potential of the Cosy right now. And that's because we're always trying to balance the three things that really matter for customers, which are the comfort of the home, the upfront cost, and that lifetime running cost that really create value over time. And part of that is, one, how we design the system, and two, the tariff that you pair it with. So we think of this as a package of value for the customer now, rather than just a heat pump at a flow temp aiming for a certain SCOP. So it's about making the whole ecosystem work together. But for now, we are designing a 50-degree flow temp.
And what's the maximum flow temp this can run at?
This can run up, we tested up to 65, so it is a high temperature heat pump. And again, it all depends on how we choose to design the flow temp, and then also the firmware can do different things in terms of how we drive the temperature curves in the heat pump.
So long term, as we're looking towards people taking out gas boilers who don't want to do full installation upgrades to old houses, essentially the Cosy6 could benefit them running at 60 and basically changing nothing in the house essentially.
Yeah, I always caution that we would never say change nothing, because that always presumes that the radiators were sized properly.
Let's quickly talk about what the engineers did before they left. They took up all the plastic cling film they put on the carpets and the stairs, and they also hoovered afterwards. They were by far the cleanest workmen I've ever had in my house. Let's just talk about what it was like for the engineers to commission this. Now, they haven't done one of these before, apart from outside the training place. This was their very first Cosy6 install, so it took them a little bit longer to kind of figure out some finessing things at the end, but eventually they kind of reread their notes to refresh their memory and basically sailed through it pretty quick. Obviously, the more and more they do this, the faster and faster it's going to become commission. But as you can imagine, their first physical one on site with a customer stood over them with cameras was a bit daunting, so I turned the cameras off, kind of left them to kind of do it, and just kind of, they were quite interested to show me how they were commissioning it, because it was the first one themselves, so they were quite excited. It's then up to me to then commission my side, which they were also quite interesting to see, because they've never seen the customer side of the service. So I scanned the QR code on the front of the Cosy hub, which is in my loft, and after I've done that, it goes through some processes in there about adding it to the Octopus app. Now, it's the same Octopus app you're going to be using for your billing, for your meter readings, and also if you're an intelligent customer like me, it's the same app you set your car intelligent, and you see everything like that. So it's under the devices section of that Octopus Energy app.
The Cosy Hub itself can support up to 4 zones, one of those being your hot water zone. So you could have potentially 3 space heating zones.
And the pods that come with it,
correct,
are they temperature sensors or just boosts?
They are all temperature and humidity sensors, and within each zone you will have one pod that's designated as primary, and that pod will allow you to do a temperature boost as well. That is the one that sends sort of execution instructions to the controller, and any additional pods that are assigned to that zone provide room by room temperature and humidity readings to help the system work better and provide us more data over time.
You've just answered the question I was going to ask you, which is, I'm assuming that you're going to use the pod sensor data as well as the external sensor data to sort of use that analytical data to work out the best way of running the heat pump at lower modulations, lower temperatures occasionally.
Exactly. All that data is part of how we learn about how the heating systems are working in real world installations, essentially in real homes, outside of laboratory environments. And it's also useful for customers because in the app you can see the temperature humidity reading for every room where you have a pod. So that data is accessible to you as the customer.
I can see everything from controlling the hot water, controlling the zone 1. So I've only got one zone. The Octopus Cosy will, obviously, as we've heard from TJ, do more zones in the future, but I can just basically see all the humidity data and temperature data directly from the Octopus Energy app. Now I can also set schedules in there, I can boost the heating directly, or obviously I can use the pods that are throughout the house for boosting the energy of the service. Now the only thing that you can't do, which I think Octopus do need to look at doing in the future, I've put a couple of the pods, one's in my lounge, one's in my main hall where my old thermostat used to be, and two of my other pods, one's outside the bedroom and one's outside the main bathroom. Now what I think Octopus should do is allow you to reconfigure what the boost button does. Now at the moment the boost button just boosts the central heating, but it would be nice if you could choose certain pods to maybe boost the hot water. Like an old emergent heater, this actually powers the hot water rather than the emergent heater inside the tank. But we could have a boost button outside a bathroom. If we're going to need a little bit of hot water for a shower or a bath and we're running low, hit the boost button outside a bathroom. If we could redesignate what that boost button does, Octopus, inside the app, that would be great. Now at the moment, Home Assistant doesn't have any of the APIs built into the Octopus Energy API by Bottlecat Dave, but eventually it will get there. There's just limited numbers of people, Cosy6 and heat pump systems inside the Octopus app, but eventually you can expect that the API will have all that data in. Supposedly the API is already sending data to the Octopus API of what your heat pump's doing. We just need someone to work in integration of what that can see. But it is an absolute fantastic app. I can control the temperature in the summer. I can control the temperature in the winter. That's the total temperature the heat pump will hit for the flow temperature around my house. So it's got a lot of design spec that you can mess around with to really kind of boost your savings. Now the max temperature is set by your engineers, and that's what they've commissioned your flow temperature at. But as you'll see, you'll be able to probably play and have lower flow temperatures, giving you a better SCOP, better efficiency of the heat pump. The main thing about Octopus Energy is you'll be able to run this kind of around your intelligent hours and other hours, and that will basically give you a much cheaper running rate than gas. If you're interested in getting one of these, don't forget there's a link down below at the bottom where you get to spend £200 with me. In other words, £100 off your Octopus install if you're getting a Cosy6 or any heat pump fitted by Octopus Energy. If you want to know how I'm running this off solar and batteries, and if you're interested in learning more about batteries, see this video here. And if you don't know what Octopus Intelligent is and you've got an EV, then maybe see this video here.